Hello everyone. GM. Sorry for the little delay. We were just having some technical issues. I hope everyone has been doing amazing, that you had a great weekend. We're kicking off this week with one more hackathon workshop. Today with me, I have Gal Sagi, CEO from Hypernative, and he is going to talk to us today about best practice for detective preventing risks in Web3 development. So yeah, Gal, whenever you're ready, feel free to take it away.
Sure. Thank you, Sophia. Hi, everyone. I'm Gal Sagi, CEO of Hypernative. Hypernative is a Web3 real-time security and risk prevention platform for protocols, chains, and asset managers. I'll start maybe with a brief introduction about what is Web3 security, why do we need real-time, what are the security options that exist for projects today, and then I'll show you a bit of a demo about Hypernative and the capabilities that will demonstrate what we can do. So in a nutshell, today most of the people are familiar with two types of security things that they need to do to their protocols and development. One is an audit process. You hire a security company. They look at your code and create a report on various vulnerabilities that they find, usually before you deploy the code on chain. And then there are other bug bounty programs that you let people report if they find anything about the project. But when you look at security in other domains, usually security is a more broader layered approach where you have that thing that happens before deployment, but you also have other layers of protection. And the layer that I'm going to show you today is what we call real-time monitoring, which is essentially being able to monitor on-chain activity. And this on-chain activity could be transactions, it could be contract creations, it could be multi-sig or wallet operations, it could be governance proposals and others, combined with off-chain data, where the idea is to find out any malicious or security-based incidents before they happen and help you prevent them in real time. So few of the problems with an audit process is that first it's something that happens before deployment, and a lot of development teams usually try to introduce new updates after they have done the initial audit, and then these new things usually a lot of times they don't audit it again, and these introduce what we call an audit drift, which is essentially meaning that they have introduced risks that they have not been audited. A lot of times also there are attacks that are happening in various different vectors that audit process couldn't have caught. Like one example was there was a Viper compiler bug that happened on Curve protocols. So some protocols got hacked a few months ago, where essentially it was a bug in the compiler. So if you look at the code before it was compiled, there isn't any problem in the code, but it actually translated to a bytecode which was not operating correctly, and this was exploited. And there are various other vectors, right, that are that an audit cannot catch, like operational. Someone stole your private key of your multisig, and that multisig is controlling the contracts. And in the end, right, like you can't really think about all the end-to-end scenarios and possibilities that your protocol is going to get hacked or exploited. And this is exactly where real-time protection comes into place. So obviously there are various, I think today, various vendors in the space. I think as a protocol developer, you have the opportunity to assess and look at these solutions and understand what fits to your needs. I'm going to show you Hypernative and the capabilities of the system. And teach you what is possible out there. So I think one of the remarkable thing that we found out in Hypernative, and this is something that we have done a very extensive research on, and we looked at all the hacks and exploits that happened in the last year plus and in Ethereum since Genesis. And what we found out is that using real-time monitoring, we can basically detect all of these attacks. And in 98% of the cases, we are able to detect the attacks before they happen. And this before is happening few minutes before the first hack transaction. And I think this is a very big misconception of the industry, that a lot of people thinks that attacks are happening in one transaction and then there is nothing you can do. I think that what we have seen and our experience is that this is not the case, and it's very hard to deploy an attack like that. And usually there are indicative signals that are happening before an attack is happening, and these are the signals that Hypernative knows to detect. So we've created, for the customers that uses Hypernative, there is a big list of past incidents, like just recently the Raft Finance incident, which Hypernative detected around 15 minutes before the first tech transaction, and a lot of other different type of incidents that we actually wrote reports on. But in the system, you have three parts. So the first part is what we call a watch list, where a watch list is essentially a list of assets that you want to add and monitor as a protocol writer. So you are writing your protocol, you are deploying them, and then you can add the specific contract addresses of your protocol. You can add your multi-sig wallets. You can add specific protocols, like all the core contracts of a protocol. If you're using multi-chain and you want to track bridges, you can pick bridges. So anything that has an on-chain address, you can add here. And as Hypernative, we don't need to do any integration with your protocol. So we already cover in the chains that we monitor, we cover all the different contracts or protocols that are running out of the box. So you can already add this, and this is all the integration that you need in terms of the detection, right? So you add the contracts that you want to monitor. And in this case, I picked an example of a protocol called Jimbos. Jimbos is a protocol on Arbitrum that got hacked for $7.5 million on the end of May. And I've added as an example that the token contract and the liquidity book token contract, but I could have added all sorts of other, like multi-sigs and other contracts of the protocol. By the way, a lot of times you also integrate with other protocols or oracles or any other third-party providers, and you might also want to monitor these, so you can also add them to your watch list. Now, after you've added everything, you start getting what we call risk insights, where risk insights are a real-time deduction of risk that the system find out in real time based on on-chain data, and we also collect mempool data. And we use the variety of techniques to detect risk. So obviously the most important and why we are discussing here is security, right? Essentially detecting hacks, exploit, or anything before it happens in an actionable manner. And I think one of the important elements when you are detecting security events before they happen is first that you are detecting as wide as possible, right? Like you are detecting all the possible different vectors that your protocol might be manipulated. And it could be through smart contract bug that you introduced and the audit missed. It could be through operational problems with your wallet. It could be because of your front end, right? Got compromised for DNS hijack or something like that. So there are a variety of different vectors, and Hypernative today knows to cover all of these vectors and alert you in time before the problem happens. We also have different type of categories that I'll not focus too much, but we have technical risks in the system, so you can track like contract upgrades, multi-sig ownership changes, staking risks that we have, node infrastructure risk, financial risks around market manipulation, large money movements, price divergence, liquidations, and others. Governance, and this is something that some people don't know, but governance proposal is another an attack vector that Hypernative is covering, which is being used in various few attacks historically happened through governance proposal, and the entire on-chain deployment of code is another, right, an attack vector, because in the end you are auditing a specific code, but then how do you verify that what you actually deployed on-chain is the exact same code, and is there no something additional there that was added by someone malicious along the way? So being able to track governance proposals, being able to track code changes through governance proposals and governance tokens is another important area that real-time solution, real-time monitoring solution should cover. The other part is being able to detect phishing and scamming campaigns. So by using and looking at on-chain data and, of course, off-chain data, you can actually understand malicious campaigns that are doing phishing or scamming on your tokens or protocol. And with the help of Hypernative or other vendors, you can help basically to remove these campaigns. So this is another very important options that you should consider when you are picking a real-time monitoring, and something that you should address in your protocol, right? Like you don't want your community or users to get phished or scammed. If you can help them somehow avoid that, it's important for your protocol. So a lot of out-of-the-box detections, and I'll go over the case of Jimbos just to demonstrate some of the things that can be detected beforehand. So if you were the Jimbos protocol, by the way, at that time, you would have gotten these alerts in real time that you see here, where if I take this exploit suspected alert that was triggered on 12:24 a.m. UTC, that's the actual hack transaction. And you can see here that Hypernative essentially identify. But by the way, I just want to know, do we want to stop for questions, or we do it in the end, or there is no questions? Just so.
At the moment, we had a question a couple minutes ago regarding what about normal users, as I believe you were specifically mentioning a type of certain users to use this platform. But if there's no questions at the moment, we can definitely go through them at the end. Or if you
Okay, sure.
if you
Yeah.
see any questions popping by, feel free to answer as well.
Okay, because I can see the question screen, so if there is something, but we'll cover that in the end if that's okay from everyone.
Yeah. Yeah. Okay. Perfect. I will let you continue.
Thank you. Um, so in this example, we see here the alert that was triggered on 12:24 a.m. UTC. That's the hack transaction. Like that's the first hack transaction. You see that Hypernative identify the attacker. It identify the victim of the attack, like the specific contract, which is again a very important thing, right? Like when you are getting alerts, you want them to be as indicative as possible and the impact of the attack. And the interesting thing about it is that 7 minutes before that first hack transaction, Hypernative actually alerted about this hack. And the vector that we use here is what we found out is that there are very indicative signals that are usually happening before a hack is being carried out, uh, basically detecting the attacker, right? So Hypernative today has two type of detections. One is detecting vulnerability that is exist in your protocol due to common vulnerabilities that we have identified and real-time monitoring. The other is some sort of an abnormal behavior interacting with your protocol in variants, in storage, in transaction. And the other third part is essentially detecting an attacker preparing to do an attack against your protocol. And I think this was actually a very successful metric for us because in the end, we found out that no matter what is the vector of an attack that is going to be carried out, the attackers still need to do some sort of a preparation steps, and there are various kinds of preparation steps that an attacker could do. One of these types is that they deploy a smart contract, and that smart contract is actually the attack contract. And we treat this problem very similar to how we would treat like a malware or an antivirus solution in our personal computer. We analyze at Hypernative today every smart contract that is created on chain. And based on this analysis, we know to say if this is an attack contract, and if this is an attack contract, who is it going to attack? And is it something that relates to you as a protocol or your contracts? And we found out that this process is very accurate today. We give it a machine learning score. It's based on variety of different metadata and bytecode of the contract itself. And this is one aspect that we do. And this is like if you are the target of what seems to be a very accurate attack, then you probably should take some sort of an action. Another vector that we do today is we have a forked environment of the blockchain where we simulate and fuzz these things. So we can actually run, we actually Hypernative, what you see here as simulated is Hypernative actually ran this attack 7 minutes before the original hacker actually triggered that attack. So we knew the outcome 7 minutes before that. And there are many different other type of vectors that we know to detect, and this number is increasing every time because again we invest a lot in our security and machine learning team that keeps finding more and more of these indications that an attack is going to happen. And for us, and I think if you are assessing, of course, a solution or if you want to use real-time monitoring, I think two important questions are what are the vectors and the methods that you as a vendor use to detect to see that it's as wide as possible, right? To be able to detect all the different vectors of an attack with all the different methods. And then you also want it to be accurate because you don't want to get an alert every like 10 minutes that someone is going to hack you when there isn't an attack, right? So you want the system to be super accurate, and usually this accuracy is achieved by the classification methods that you use to detect to determine what is an attack and what is not. Um, so we have also a timeline view that shows you all of these right in a timeline, even though there is a timestamp here. And I think what the other part of this angle is what to do, right, based on these detections. So once you have these various different detections, and this is, by the way, a process that we, when specifically at Hypernative, when we work with a protocol, it's something that we help them. We allocate a security researcher to look at the various, risks that we want to cover, help you identify all of these points. The system anyway, out of the box, detect them. But usually what you want is to define what we call a policy, which is, okay, now that I have picked, right, like have a detection, what do I need to do about it? And Hypernative today has a variety of things that you can react on an alert. So obviously you can send it to email, Slack, Discord, Telegram, like any messaging channel, or to a webhook. So you can also send it to your API and decide what you want to do with this alert in a programmatic manner. But what Hypernative also has are options to actually trigger a very efficient transaction in real time. So Hypernative, you can pre-sign a transaction with give a specific role to Hypernative. We know to integrate with your operational or security multisig and essentially trigger an action, a transaction on chain based on that, which is really depend on what are the capabilities that you have as a protocol, right? Like you want to pause the entire protocol, you want to limit the protocol somehow, you want to blacklist a specific address, you want to time lock a transaction. So there are a variety of different things that we can do together, and it really depends on your preference as a protocol. And this is a process that we usually do together to define what is the relevant action to do based on the detection. As you also saw, we are a partner of Chainalysis. So Chainalysis uses this platform as well for their incident response team. So you have a lot of recovery actions as well, and you can basically forward these alerts also to Chainalysis. So you can have, if let's say you don't have any automated process or you don't want to do any automated process, you can still essentially have a very expedite process of recovery and post-incident help to basically handle and investigate the incident that happened, help you recovering the funds, and so on. We also, as you saw, maybe have integration with OpenZeppelin Defender. So if you use OpenZeppelin Defender, you can use Hypernative alerts to trigger that. So this is one part. The other part is essentially what we call custom agents, where custom agents is essentially everything that you saw until now are out of the box, very actionable alerts that Hypernative can trigger. You just add the assets that you want to monitor, and you can get all of these alerts, which are, again, very accurate and specific and actionable. The custom agent part is essentially let you, as a protocol, define custom logic that you want based on any on-chain event that is happening and get alert on it. So you can basically monitor any on-chain event that you want with a very big library of templates and get an alert. You can customize this. You can check few things together and then add them. You can check things historically as well, because we index and keep all of this information. So you can have things over time or in one transaction. And we check and we run these kind of checks or custom agents for you every block. So for people that are familiar with FOTA, for example, so this is a very simplified way to create like the same detections that you can model there, and a lot of others, because again, we also have the historical data. We also using, like, you have like machine learning models that you can use here to understand abnormal behavior if you don't know a specific threshold, and so on. So this is, you can treat it as a security, or you can treat it as like operational or performance monitoring that we do. So I think that's in a high level, anything like real-time monitoring. I would maybe stop to have some questions and answer some things about real-time monitoring, security in general.
Thanks, Gal, for sharing with us. I don't know if there's any questions that you would like to do. Jan here actually explicit that. So we had, what about normal users? But he meant users that are being targeted.
Yeah, so we work today mostly with like the type of customers of Hypernative is mostly protocols, chains, and big asset managers. We do see that the platform is very good also to detect like fraud and phishing and scamming campaigns that are targeting retail users, and we I think hope to bring that technology to more retail users or users that are using wallets. Some of our, by the way, the work that we are doing with asset managers is about them being able to withdraw a position based on Hypernative alerts. So if there is a problem happening in a protocol that you are invested in or that you are part of, you can actually automate the process to withdraw the funds from that project and save the funds. And today, because we see that technology works pretty well, it essentially found out all the hacks and exploit that happened in the last year, and in very high percentage found it before it happened. We hope to bring that technology over time to more and more users, even retail users. I hope that was the question, at least. So.
Rest in peace, insurance protocols. Okay. Any other questions that you might have? Drop them in the chat. We'll wait a minute.
Yeah, maybe until someone will have any questions, I want to. I think in the end, like the reason why we started Hypernative was to help protocols users. In the end, I think that what we are seeing is, right, like you're building a protocol, you're building a project, you are a developer. A lot of you don't have the necessary security expertise, and bringing a security person in-house is usually an expensive manner. I think it's hard to keep track as a project on all the different kind of vectors and attacks and things that can happen to you. But for us in the Web3 space, we are a very big and lucrative targets for bad people, because like the incentive for them is very clear. They have funds, and when they steal and hack your protocol, they get instant money, essentially. So we are trying essentially to be that security advisor or platform that helps you cover all the things that are maybe, maybe you are not familiar with, or that you are, still starting and not, don't have the funds or the capabilities to hire a full team to handle that. And you need a full team to handle all the different kind of security. So I think that's the reason. I think also what I would love to say is that we need to start thinking about security as a layered approach. There isn't one solution that fits everything and that can solve everything. Usually when you think about security, and it's true, by the way, it's true to Web3, but it's also true to Web2 and any other big organization or small organization, right? Like in the end, security is about limiting and making the hackers or the bad guys have a very hard time to do what they do, to make it easy or efficient for them to do that. And usually you want to use, so you said RIP on insurance protocol, but it's usually you want to have all of these layers, right? You still want to do the audit, you still want to do the bug bounty program, you still want to do the real-time monitoring, and even maybe the insurance, either protocol or provider, to have that full coverage. Of course, right, like budgets and things like that are consideration that you need to think where you want to invest most of your budget. But I would urge you to rethink, right, when you set specific budget to security, understand, and the reason why we did this session is for you to understand an example of what is out there in terms of monitoring and what it can do. So consider all the different options that you have when you're developing, and in the end, right, like the goal is to make sure that everything that you're building is protected, because it's unfortunately very easy to ruin, years of work of someone with a hack or exploit. And we really want, I think, as an ecosystem, to try and reduce the amounts of hacks and exploit that we are experiencing in the field.
Sure. Thank you very much, Gal. There's no further questions at the moment, so I think we can call it an end.
Sure.
Thank you so much. Yeah, go ahead.
No, thank you for having me. Sorry for being late. It's my fault. And if anyone wants another, like, discuss with me or us, if you want to, by the way, even free consultation about any security questions that you might have in your project, if you're a build partner of Chainlink, or else, feel free to approach me. My email is gal@hypernative.io, so feel free to approach for anything.
Okay. Thank you very much, Gal. And I hope everyone has an amazing rest of the day. And I will catch everyone at our next workshop. Thanks, everyone.
Thank you. Bye.